Dear students, welcome to this practical session. In this session, we are going to discuss the next lab cycle program, that is a program to convert infix expression to postfix expression. Given an infix expression, this program should give you the postfix expression. Include the preprocessor directories, hash include stdio.h, then hash include conio.h. Then I'll declare a string array, that is char postfix. So this postfix array is going to store the postfix expression, postfix of 50 and infix of 50. And this infix array to store infix expression. And then I'll declare a stack of size 50, and this stack is used to store the operators and braces. Okay, and next I'll declare an integer variable called top with the initial value -1 to point to the stack data structure. Next I'll declare main method void main. Within main method, let us read the infix expression. Printf, enter the infix expression, /n, scanf, %yes. We are reading infix expression as a string, a sequence of character into the infix array. Okay, so need not use a for loop and braces here, because we are reading a string, a sequence of character at a time into this infix array. Okay, next I'm going to print a message. Printf, the entered infix expression is %yes, comma, infix. Okay. Next, in the next line, I'm going to call a function called infix to postfix. So this function is going to convert the given infix expression to postfix expression. And now we will print that postfix expression. The postfix expression is %yes, /n, comma, postfix. The postfix array stores the result, that is the postfix expression. Here also /n. Next, I'll write getch and main method close. Now we are going to define this infix to postfix function. Okay, infix to postfix. Then within braces, first I'll compute the length of the infix expression. Okay, so I'll write int length, then length equals to strlen, which is a built-in function, strlen of infix. The length of this infix array is computed. Okay, and now we are going to scan every symbol in this infix expression using a for loop in for I equals to 0. I'll declare this variable here, I less than, yes, length, comma, semicolon, I plus plus. Next, within the for loop, first I'll read the symbol. Symbol equals to infix of ith symbol. Infix of ith symbol. And next, we are going to check the symbol, switch. I'll use a switch statement. Switch symbol. Okay, so let me define the cases. Case 1 is opening parenthesis. If the symbol that is scanned is an opening parenthesis, what we have to do? We have to push that symbol to the stack. You have to push that symbol to the stack and then break. First case is over. Now I'll define the second case. The second case is closing parenthesis. So when the closing parenthesis comes, you have to pop operators from the stack until opening parenthesis is encountered, right? So I use a looping statement to repeatedly pop operators from the stack until closing parenthesis is encountered. So while next symbol, I define that next variable also as string in the sense character type. So character symbol, have not defined this variable symbol, which is of character type, have defined sim, and then I'll define another variable called next. Okay, while next equals to pop is a function that we are going to define. If the next symbol is not equal to opening parenthesis, then you have to repeatedly pop it, right? Then while bracket open, postfix of pop the symbol and place it to the postfix array. So postfix of p position equals to next. That is the next symbol that is scanned. Okay, and then while close. Here I have to define this variable p, which points to this postfix array. So I'll define that variable p here with the initial value 0. Now the first symbol that is popped is placed at this postfix of pth location. And next we have to increment that p plus plus. Okay. And this completes the second case. Next is break, semicolon. Next, the third case. The third case is dealing with operators. If it is a plus, if the case is minus, we need to compare the priorities, right? So I'm writing all cases, star, and then if it is division operator, if it is an operator, what do we have to do? We have to check whether the stack is empty. If the stack is not empty, so here is empty is a function that we are going to define later. If the stack is not empty and the priority of stack top element is greater than or equal to the priority of the symbol. If it is greater than or equal to the priority of the symbol, what do you have to do? You have to pop that symbol and place it to the postfix array. So postfix of p equals to pop. And next p plus plus, increment this p, and then while close, then break. You are going to compare this operator priority, and if the operator priority is greater, you are going to pop the symbol from the stack and place it to the postfix size. And at last, you're going to push the scanned symbol by writing push symbol to the stack. Just recall the algorithm that we have followed to convert infix expression to postfix expression. Okay. And now the last case, that is default case. What you have to do in the default case also, simply you're going to push. In the default case, that means the scan symbol is not opening parenthesis, closing parenthesis, or any operator. Then by default, it will be an operand. What do you have to do when it comes to operand? You have to place it to the postfix array directly. Postfix of P equals to symbol and then P plus plus. Okay, then switch case close and okay, I'll do one thing. I'll write postfix of P here itself P plus plus. So there will be no confusion. Then switch case close. Then for loop close. Okay. So after this, you have, it means after closing the for loop, it means you have scanned all the symbols in the infix expression. At last, what we have to do to obtain postfix expression, we have to check whether the stack is not empty. If the stack is not empty, pop all the operators from the stack and you have to place it to the postfix array. So for that, I'll write while is not empty. If the stack is not empty, postfix of P plus plus equals to pop. Pop all the operators from the stack and place it to the postfix array. And at the end, after popping all the operators from the stack and placing it to the postfix array, you have to append postfix of P position. You have to append null character to mark the end of the postfix array. Okay, and this completes the main method. Okay, now we have to define the functions that we have used earlier, that is push function, pop function, and isEmpty function. And here also, priority is a function which checks the priority of the operators. So that function should also be defined. Priority. Okay, now let me define push function first. I'll write push. To this function, you have to pass an argument, that is an item which has to be pushed. So to the stack, we are pushing operators and parentheses, right? They are considered a symbol, hence the data type of this item is character type. Next, bracket open. If the top of the stack is not equal to maximum size, have to declare this variable maximum size -1, then the stack is not full. So in this case, you can increment the top pointer and to the stack of top position, you are going to push the item. Then if close, else printf stack is full /n. Okay, then else close, then push close. Okay, now we are going to define the pop function. Pop, bracket open. Then we are going to check whether the stack is empty by writing if is empty. If it is not empty, then Then you're going to pop the element, right? So I'll write return the of stack of top element minus minus. After returning the stack topmost element, decrement the stack pointer by 1. Hence, I'm writing stack of top minus minus. Okay. So then semicolon, bracket close, semicolon. If it is not empty, then if it is empty, if it is not empty, return the topmost element of the stack and decrement the top pointer by 1. If it is empty, then else printf stack is empty /n. Okay, now we have to define is empty function. So pop close, and now I'll define is empty. So this method will return an integer value, hence I'll write int is empty, then bracket open. If top of the stack equals to -1, then I'll write printf stack is empty. So here need not print the statement, just return a value that is sufficient. So instead of printing, I'll return a value. So return 1. So if this functions return 1 means the stack is empty. Okay. Else return 0. Since there is only one statement that has to be executed after satisfying the condition, I'll just remove this braces, flat bracket. Okay. Then is empty is closed. Is empty is closed. I hope you understood. If the stack is empty, this is empty function will return 1. 1 means true. Okay, if the stack is not empty, it will return 0. So 0 means false. That is what the convention we have followed. Okay, and now at last we have to define priority function. So this function accepts a symbol whose priority needs to be checked. Okay, so the return of this priority function return type I'll consider as integer. Later, this integer value that is returned by this priority function will be compared. Next, I'll write opening parenthesis, switch. I'll pass the symbol. Okay. Next, case 1. Case, what is case? It is star. Both star and division operator. Both star and division operator will have the same priority. Hence, I'll write return the priority as 3. Okay, these values 3 to 1 are nothing but the priority value. So these values are checked later. Next case is a plus operator, and then the priority of both star and division operator is same. Hence, we are returning a single value 3. Okay, and the priority of plus and minus is same. Hence, we are going to return 2. Okay, and at last, we are going to send the priority of opening parenthesis. So the opening parenthesis priority is considered as low. Hence, I'll write 1 here, return 1. And next, by default, if there are any other symbols apart from these operators on the stack, return 0. So for that, I'll write for default case, return 0. So this completes the priority function. And now we will compile the program to check for any errors. So looking at the error message, don't be panic. We can fix up the errors. Okay. So the first error is function infix to postfix should have a prototype. So I'll define a prototype for this function. So it is void infix to postfix. Okay. And then compile, type mismatch in redeclaration of infix to postfix. Okay. Infix, check, just check for the spelling. Infix to postfix. Yes. Infix to postfix. Compile. Then string length function should have a prototype. So I include a header file called hash include c type .h. So this header file contains a body for this string length function. Okay. I'll type this also in fix to postfix semicolon void infix to postfix. Now I'll compile. So, okay, switch should have a prototype. So there is a spelling mistake here. Switch. I'll include string.h header file here. String.h header file. Let me compile. Yes, one error has reduced. This string length function is provided by the string.h header file, not ctype.h header file. And I have to include the prototype for push pop is empty. I'll do that. Void push character pop. To this push, we are going to pass an item. Okay. And then int is empty, semicolon. Then int priority of the symbol, that is of character type. So these statements are called as prototypes in C language. Just compile. Okay, while statement missing. I'll write void while statement is missing. Type mismatch in redeclaration of push. Okay, so I'll specify void as return type. And then, yeah, there is some braces missing. Is empty and priority of stack of top. Stack of top is greater than or equal to priority of the symbol. I hope it is clear. Yes, I have to declare MS, that is maximum size, with the value 50. So here I'll declare MS equals to 50. type mismatch in redeclaration of pop. So pop will return character type, hence I'll define character pop. Now undefined symbol stack. Okay, so this stack where S is capital letter. In this stack, S is capital letter. See, looking at the error message, you can easily fix the errors. Don't be panic when you get a lot of errors. Obviously, when the program is very lengthy, you will get lot of error messages. You can fix up the errors. Once you know the syntax of the language, you can fix up the errors. Now, there are no syntactic errors in this program. We will run the program now. I'll give a simple infix expression A plus B. So what should be the postfix expression? It is AB plus. You got the expression. And let me execute for one more input. So I'll give a different input A plus B star C. So you should get A, B, C star plus. So this is the program. You can check for some other inputs. I hope all of you have understood the program because we have solved many problems. We have converted many infix expression to postfix expression. We know the actual procedure that we used to follow to convert infix expression to postfix expression. Once you are thorough with the procedure, you will easily understand the program. Okay. Thank you. Thank you for your patience listening.